All right, everybody, rounding the bend. We are on question number 5. Let's take a look at this. This is 7 marks. Pretty complicated, I suppose. Deals with perpendicular bisectors and then the intersection of two lines, essentially. Let's read a question and see what we can do with it. Two schools are represented by points A, 220, that's point A, and B, 1424. Those were those two school lies on the coordinate plane. And they're on the graph below. A road represented by the line R with equation negative x plus y equals 4 passes near the school. An architect is asked to determine the location of a new bus stop on the road such that it's the same distance from the two schools. If we want the same distance from these 2 points, we're going to want to set out a perpendicular bisector. Okay, what are they asking us to do? They're asking us to find the equation of the perpendicular bisector of AB, giving the equation then in the form of y equals mx plus c, and then after that we want to find the coordinate of the point R where the bus stop should be located. Okay, so what are we talking about when we're talking about a perpendicular bisector? Well, we're talking about a line. So here is the line segment AB. That's a little funny. Here's a line segment AB. It connects A and B together. The perpendicular bisector is going to be the thing that goes right through the middle of these two lines. So it's going to be perpendicular to the line segment, and it's going to cut these exactly in 2 equal halves. So, and what does that do for us? What does that do for us? Well, it means that the distance, constructing some kind of isosceles triangle, the distance anywhere, as long as we follow this central line right here, this center line right here, the distance between A and some point will equal the distance from B and some point. That is to say that these two lines will be equal. That's what the perpendicular bisector does for us. So how do we find the perpendicular bisector? We need to find a line perpendicular to this line, AB, and then we need to find a line that also passes through the midpoint M. So let's go ahead and deal with this section first. We want to find a line perpendicular to AB. Perpendicular to AB, well, we're going to need to find the slope of AB before we can get started on that. So let's go ahead and find the slope of AB. Let's write this MAB. That's what we're trying to find here. MAB. And what do we know? It's always a change in y as change in x. In this case, I think it's actually just going to be easier to use the slope formula. Remember, that's change in y over change in x, and you have this in your formula booklet. It's y2 minus y1 over x2 minus x1. I think it's always not a bad idea to actually label these as x1 and x2, because you do have to be consistent when you write these out. y1 and y2. Okay, so let's go ahead and write out this slope formula. Equals y2 minus y1. So y2 we called 24 minus y1 is 20 over x2 minus x1. x2 we called 14 minus 2. And then we can go ahead simplify that. 24 minus 20 is 4. 14 minus 2 is going to be 12. I think we can simplify that, divide everything by 4. This is going to be 1 over 3. Okay, so MAB is equal to 3. MAB, that is the slope of line AB, is equal to 1 over 3. And so what does that mean? That means M perpendicular, if we want to find the perpendicular slope, the slope that's perpendicular to MAB, well, it's going to be the negative reciprocal. Remember, reciprocal means switch the top and the bottom. So this is going to be 3 over 1, and we want the negative reciprocal. And that's going to be negative 3 if we simplify that. Okay, so that helps us out. We now know the slope of this line. So what is the equation of a line? The equation of a line is y equals mx plus b. And we know what m is. We know what m is in this case. It's negative 3. So we can go ahead and rewrite this as y equals, we say, well, negative 3x plus b. But we still don't know what b is. And we have 3 unknowns, right? We have y, x, and b. But x and y are an input. So as long as we can input one coordinate point, some set of xy values, then we can reduce our 3 unknowns to 1 unknown, and then we're just going to have 1 unknown and some values, bring everything to one side, and we can solve for that unknown. So let's go ahead and do that. They give us a point M. Actually, no, they don't give us a point M, so this is the second part. We need to find the midpoint. I guess that leads us to the second part right here. Passing through the midpoint, point M. Okay, so let's go ahead and find the midpoint. Let's go ahead and just write out another kind of line right here. Midpoint. What is the midpoint? Well, we know the midpoint is going to be the average of the x's. x2, actually just x1 plus x2 would be fine. x1 plus x2 over 2, and y1 plus y2 over 2. We already labeled these x1 and x2, so I think we should actually be okay in just using those values and using that same kind of ordering. So this is going to be 2 plus 14 over 2, and we have 20 plus 24 over 2. And then what can we do with that? This is going to be 16 over 2, which will give us 8. Clean that up. And 20 plus 24 is going to be 44 over 2, which is going to be 22. Okay, so that's our midpoint. Okay. So, for the sake of space, what can we do? Let's just write it up here, actually. So we had this y is equal to negative 3x plus b, and we said if only we had some x, y values that we could substitute, we could find b, and now we have them. So let's go ahead and substitute those in. Y is equal to 22 equals negative 3, x is 8 plus b. 22 is equal to negative 3 times 8 is going to be negative 8, 16, 24 plus b. B is equal to, we can do it both ways actually. Negative 24 onto the other side is going to become positive. 22 plus 24 is going to be 46 is equal to b, or, little crunch for space, b is equal to 46, all the same. Okay, so what does that do for us? Let's clear some space here. Y is equal to negative 3x plus b. We found b to be 46, so we can write out y is equal to negative 3x plus 46. Find the equation of the perpendicular bisector. Give your equation in the form of y equals mx plus c. And there it is. Y is equal to negative 3x plus 46. Okay. Now we want to find the coordinates of the point R and where the bus stop should be located. Okay. So we have one equation, y is equal to negative 3x plus 46, and we have the equation of the road itself, this equation R right here, and they told us that is negative x plus y is equal to 4. I think the easiest thing, actually these numbers look okay, so we could actually solve this algebraically, but if we're finding a pair of coordinates, sometimes it's quicker just to graph these. If we want to graph these, we need to have an equation in the form of y equals mx plus b. So this is almost there, but we're just going to have to write y is equal to, bring this negative x over here, this is going to be x plus 4. So now we've got two equations. Y is equal to negative 3x plus 46, and y is equal to x plus 4. Let's see. I guess the one thing, if you get a question like this and you think, this y-intercept looks a little funny, 46, is that correct? If you look at this line right here, just because I was wondering, is this correct? I'll check the mark scheme. I think it's correct. But negative 3x, it's definitely a negative slope. And where might it intersect the y-axis? That is to say, cut this line right here. 46 might actually not be all that bad. So that looks okay. Okay, so let's go ahead, graph these, and find the point R where the bus stop should be located. Okay, so let's go ahead and let's look at this. I think we're good actually. Let's go into, in this case we want to graph this, and we will have one line that's negative 3x plus 46, and then menu, graph entry, graph another function, and it's y is equal to x plus 4. Okay. So one of these graphs is actually off the screen, so we're going to have to resize this a little. Zoom out, I'm not sure if zoom fit will work exactly all that well, but let's see. Okay, there we are. There's the point of intersection. Let's go ahead and analyze graph, find the point of intersection, and it's 10.5, 14.5, so let's write that down. R is 10.5, 14.5, and where would that put us here? 10.5, 14.5, that's bad. Let's use a different color. 10.5, 14.5. It's not like drastically different than what we might expect. That's looking pretty good. Okay, I think that finishes it up.